friends. My name's Chris, and I study psychology and philosophy. For this week's book club, we're going to be talking about free will and neuroscience. I hope you guys enjoy the talk. So for today's little book club, we're going to be going over a paper by Dr. Lavazza, I believe, and it was kind of like a review of all of the findings in neuroscience in the past 40 or odd years that have been suggesting certain claims over others, and then we'll just be going through this paper the way it went through it and seeing if there's any wiggle room for neuroscience for free will, since neuroscience seems to be threatening it, or at least that's like the common view. But yeah, this is basically the roadmap. So we'll be looking at this paper. It's relatively old, so I wouldn't be surprised at all if there have been like dozens of papers that have come after this refuting what it's trying to argue for in the end. But we'll talk about the Libet experiment, which was a really famous one that had to do with flicking your wrist and then like reporting when you decided to flick your wrist. And then some more recent findings from Soon and Haynes that came maybe like 20 years ago or like 15 years ago that suggested that maybe when there's like this type of RP or readiness potential that Libet was talking about, it can not only predict when we're going to make motor movements, but it can also predict the types of decisions we're going to make, so some content in there. And then Schurger's suggestion on like where to move forward, and then some studies backing up that. We're going to go through some interpretations and some misconceptions in these super famous free will papers or neuroscience experiments. And then finally, like his Lavazza's proposal, which is pretty interesting, honestly. It's going to go along the lines of reasoning that free will should be treated as a type of capacity, just like the capacity for creativity or any other type of like rational capacity, that it should be treated like that and operationalized like that, as opposed to a metaphysical all or nothing, we have it or don't have it type thing. And then some implication, pros and cons of that view, and so on. But starting off with the famous Libet experiment. So for those of you guys who aren't familiar, there was this really, really big famous experiment that came out in the 80s by this guy named Libet. And essentially what he did is he collected a bunch of participants and he asked them, while recording their brain signals through EEG, he was asking them, okay, move your wrist or perform some sort of motor movement. And so what he did here is he compared the signals he was picking up through the EEG with when the individuals claimed that they were actually deciding to move their wrist, or EMG onset, like the actual motor execution. Obviously, it doesn't take like much knowledge of basic physiology, that it takes time for signals from the brain to make it down to the rest of our bodies. But what you found here is that these signals preceded any type of conscious awareness or volition involved with this motor movement. And so, essentially, what he found in these experiments was that the readiness potential, or these types of signals that preceded the motor movement, they occurred nearly half a second before any type of awareness or intention or reported awareness of the hand moving. So this kind of led people to believe that, oh my goodness, maybe there is something underlying our awareness of movements. Maybe there's like a little person inside of our brain that's pulling the levers and making the decisions on when to move before we ourselves are even aware of this type of movement. And he saw that, this could happen as early as, half a second all the way to 350 milliseconds. And so the issue with this experiment is that the findings here were kind of, I want to say, blown out of proportion a little bit. People thought that this all of a sudden completely debunked the idea of free will and stuff like that, but there's some pretty key lines in this paper, or in this experiment, that Libet is very explicit about, and those are two distinctions that need to be kind of like that we need to pay attention to, at least. That of initiation, and then that of veto. So he said that, yes, there are some sort of unconscious brain processes that precede motor actions. However, there still might be a little bit of wiggle room for our what he called ability to veto or ability of free won't in the last 200 milliseconds of these motor decisions. And essentially what that means is that we have an ability to inhibit what would have happened if we didn't kind of act on it or or force our will onto it. So he's saying maybe we have this ability of free will, but it shouldn't be conceptualized in the same way most people think about it. Like, I'm deciding to pick this little hair elastic up. Maybe more so, it's along the lines of I'm stopping the already the train of events that was already going to lead to that. So like an ability to inhibit things that would have already occurred. And so he also makes it very, very explicit that this experiment was only looking at motor movements, right? And he didn't want to equivocate motor movements with volition or will, because obviously some choices, some decisions, they occur over the span of minutes, days, years. Not all of them are motor, so it would be a bit radical and a bit inappropriate to just call this some sort of sweeping claim as, we've debunked free will. Another really popular experiment that came out afterwards was one that took this idea and kind of ran with it, but instead of scanning people's brains with EEGs, which is super, super rapid and short term, and it's like this little cap that you wear on your head, they used fMRI and some fancy analyses to decode the choices that people were making. And in this experiment, people were just asked to, either choose right or left, like press a right button or a left button. And what they found is that there was a bit of a bias, not a super huge one, but there was a bit of a bias that they were able to pick up on and predict before the person chose that side. So they were able to, with 60% accuracy, more or less, which is, more than random, to predict whether or not a person was going to pick left or right. And what was kind of interesting about this is how long in advance they were able to make these predictions, or these somewhat accurate predictions, 7 to 10 seconds. And so what this kind of suggested is that maybe these readiness potentials that Libet was talking about can't only predict motor movement, but they can go a step further and predict decision making. And so all of a sudden, this this rally for anti free will was ramping up in neuroscience. But obviously, there's a lot of issues with these types of experiments. And one thing that I thought was especially important for someone who might not be really familiar with like neuroscience or the methods that you use in neuroscience is that fMRIs, they don't detect signals in a very, very short time frame. EEGs, they can pick it up at the millisecond level, more or less. Like the second there's a type of electrical activity, it can pick up on that. fMRIs, on the other hand, they scan the brain and average it out over the course of multiple seconds. So what does this mean is that signals from trial 1 can kind of bleed into trial 2 and trial 3 and so on. Since we know that decisions aren't always completely instantaneous, there's a big issue with trying to measure these types of things with fMRIs, because they just measure things in such like long time frames. Obviously, fMRI technology has gotten a lot better, but 10 years ago, I think that gap was like 5 to 10 seconds, right? So when you're trying to get someone in an fMRI and scan their brain, you're in there and it's recording 5 to 10 seconds, and a lot of things can happen before you make a decision. A lot of things can happen after you make a decision, and that's muddying all the results a little bit. And so that was one big issue with this type of research, or with this type of method to be used in these volition, free will type of experiments. Some other like limitations to this experiment was that, well, it wasn't very reason laden or like reason heavy. The participants were just asked, off a whim, just like completely exercising your will, choose right or left. And we know that most decisions in life aren't that arbitrary. When we think of ourselves as agents who are performing tasks, we take in some reasons for this, some reasons for that, and then we deliberate on it and we make a decision, right? So those are some limitations with this study. And then came Schurger and Lavazza, Dr. Lavazza, the paper that we're reading. he takes some time looking into this new model that he's kind of suggesting. And the core claim behind Schurger's model here is that in our brains, we know that there's constantly background noise going on. There's always stuff happening, more or less. And sometimes it can get integrated with what he calls like a leaky accumulator. And so movement occurs, the motor movement that Libet was talking about, it occurs when noise, this background noise in the brain, plus a weak imperative crosses a threshold. And this weak imperative can be anything as simple or as non-important as the way a task is kind of described to you, any type of internal goals you might have, contextual pressures of people looking at you, anything to do with your environment can feed into this background noise and enable a type of crossing of a threshold, which would lead to the decision being made. So this is his new model, as he called it, the stochastic accumulator model for how we come to make so-called free choices. And so another like way of thinking about it or analogy is in thinking that like, okay, the brain doesn't secretly decide to act long before you're aware of it, as some people were taking Libet to think, which he actually didn't. But really what's happening is that your brain is always fluctuating, there's always noise in there, and then an action happens, so either you do something or you kind of choose something, when those fluctuations accidentally, whether from some sort of external stimuli or some sort of non-meaningful internal state, push it over this trigger. In the same way like waves kind of make their rounds up onto the shore, it's a bit random how far any given wave is going to make it, but once it makes it to that threshold, you can say, okay, it crossed the threshold, and then that threshold is the action that we take. So not so much a little person inside your head pulling the ropes, telling you what to do without you knowing it, or making you do things without you knowing it. It's just this type of constant static and fog that sometimes, for one reason or another, gets pushed beyond the threshold, and then that's what triggers any type of movement or decision. And so the upshot of this type of model or this understanding of how we come to make decisions is that these readiness potentials and these so-called predictive signals can be seen or should be seen as processes of accumulation of noise and then threshold crossing, not really in terms of a hidden and completed decision from earlier. And so if RP is basically just reflecting all of this background noise that's going on in there, and then sometimes crossing a threshold, sometimes not, then we have to lead to reason, or then we have to kind of reconsider this way that Libet was taken to understand free will as an unconscious version of you making decisions for you to move before the case. And so what Lavazza here is kind of suggesting is that maybe in line with what Libet was actually saying, maybe consciousness, free will, volition, whatever you want to cash it out as, it has a capacity to intervene in this type of white noise and threshold crossing, as opposed to the will being something that we exercise in terms of like a decision, like I'm going to go pick up this mouse right now. What it can do is suppress noise or external stimuli that might lead that threshold to be crossed. And so some studies that Lavazza takes to support this idea, coming from Kaft here, is one where they used a real-time like brain-computer interface type thing to detect RPs, or readiness potentials, and then they showed participants actions that they could cancel, right? So they were kind of led to act in certain ways, and then they were able to exercise their free will or their volition to stop those things from happening. And so long as it happened earlier than 200 milliseconds, or what's called like the point of no return in these signal firings, they were able to exercise this with pretty significant, to a pretty significant degree. Some other kind of findings that came after this, or that were in contrary to the ideas of Libet and Soon and Haynes, were that these certain brain regions were very, very involved in voluntary inhibition. So now all of a sudden, what's happening is that like the spotlight is moving away from free will as like an active and positive type of choice, and it's kind of moving the spotlight to something closer to inhibition, or the ability to inhibit certain thresholds from being crossed or certain actions from being taken. And so basically, a little room, like they're trying to carve out some room for conscious control, at least in the inhibitory sense, to have a causal influence in our actions and all that, and our decisions. And so what Lavazza is kind of arguing at this point is that, okay, well, we shouldn't really be thinking about free will in terms of an all or nothing thing, as some of the radical, or some of the people who took Libet's experiments in an extreme to think. Maybe the better way to kind of move about this, especially empirically, is to operationalize free will as a type of capacity. So in the same way we have like strength, right? It can work in like degrees. Maybe we should kind of come up with a type of like free will capacity index, where lots of different tasks require lots of different abilities to inhibit what would have happened otherwise. And so this type of index maybe should go along the lines of quantifying things like planning, attention, memory, flexibility, creativity, and so on. And it's all of those things, it's how strong all of those things can work together, which would give us a stronger free will capacity, or a stronger, a stronger free will capacity. And so some of the payoffs, I guess, of looking at free will in terms of a capacity and not in terms of a unilateral decision-making process is that we can kind of talk a little bit more about measurable differences in individuals and also in any given task. And then we can bridge timescales, the issue that neuroscience is having with fMRI scans, right, where they can only look at a couple seconds and then what's happening in the brain within those seconds, but not particularly at any moment. We can bridge that inability with long-term, more deliberate life-scale decisions that oftentimes takes far longer than a couple seconds or a couple milliseconds. The limits, obviously, to this is that there's like there's going to be a really, really hard time squaring any type of normative responsibilities onto this index, because that's kind of still the domain of philosophy, and there's not much empirical work that you can do on that. And so basically, in conclusion, what I understood from this paper, and I really hope I'm not butchering my understanding of this whole paper, but basically what he's saying is that newer models and empirical work point towards maybe a type of like pluralism, or what he calls pluralism. So where we can exercise our capacity of free will to varying extents depending on the task and depending on who we are and like individual differences. And so he thinks that maybe if we're able to map this capacity, then we can test the different levels or test different tasks that might be associated with these capacities, and then find the neural correlates to each of those given tasks and kind of tie it all back together. I'll go ahead and like post these papers, or the general paper. That's all I had, though, a tiny bit short, but that's where I understand the current free will debate in neuroscience to be suggesting or moving towards.